Hi everyone, it's Rajiv Ramchand again. As I said in session one, I'm an epidemiologist creating these videos to introduce epidemiologic concepts to help you understand the news and the media, especially with respect to COVID-19. So this is session two about quantifying disease spread. So let's get right into it. So epidemiology really at its core, if I were to say the one primary methodological instrument that we use in epidemiology, it's fractions, which we all learned in elementary school. And just to remind you, there's really speaking, I mean, there's many different types of fractions, but there's proportions and there's rates. So a proportion is a part of something relative to its whole. So a piece of pie relative to the entire pie, for example. The rate is a frequency, so it's a proportion over a period of time. So think of it as how many slices of pie can I eat in a given day. For most epidemiologic estimates, when we think about our fractions, what I really think is important to keep in mind is that in order to be in the denominator, you have to be what we call at risk of being in the numerator. So you have to be, it has to be possible for you to be in the numerator. So what do I mean there? If we were looking at the proportion of people who got pregnant in a population, we might want to exclude men from that estimate because men can't become pregnant. So it doesn't make sense to have them in the denominator. We would want to say what proportion of women in the population became pregnant over a period of time, for example. We might want to make other restrictions as well with respect to age, with respect to some underlying medical conditions, but generally speaking, you want to make sure that your denominators always include the people or is restricted to the people who can enter into the numerator. There's four types of disease quantification measures that I want to go through with you. The first is prevalence, and it's the proportion of a population with an infection or a disease. There's two types of prevalence. First, sorry, I gave away the answer. So you have in the numerator A, which is those in the population with the disease or infection. And then in the denominator, you have those in the population with the disease or infection, and then those in the population without. So when you add the denominator together, you have the entire population that's at risk for being infected, including those who've already been infected. You want to make sure you include those in the denominator. The two types of prevalence are point prevalence and period prevalence. So point prevalence is prevalence at a specific point in time, and it's most often used. So it generally doesn't include people who died from the condition or who recovered from the condition. It just says, as of this date, this many people are infected. Today, this many people are infected. This proportion of people are infected, for example. Period prevalence will look over a period of time. So for example, it'll say, over the course of a year, this many people got infected. Now, many of them may have recovered, some of them may have passed away, but all would be included in that population. So that's point prevalence and then period prevalence. The other estimate that we often use is a rate, and that's called incidence. And it's the proportion of a population that develops a disease or becomes infected over a period of time. So we also often think of them or call them new cases or new infections over a period of time, and that's in the numerator. The denominator, however, can differ. So, and there's two different types of incidence. The first is we calculate a cumulative incident rate. And that's and in that measure, our denominator is the average population size over a specified time range. It's somewhat intuitive, and we'll go through it in the next few slides. The other measure is the incident density rate, and I think this is the one that's least intuitive. And in this measure of incidence, we're looking at the sum of time that persons in the population are at risk. So that's our denominator. It's the sum of time. We've incorporated time into our measure. And like I said, I'm going to explain what these mean. So let's assume we have a population of 5 people. And on March 25th, none of them were infected. this first case on the top row becomes infected on March 30th. The middle person becomes infected on March 26th. This fourth person, this woman, becomes infected on March 28th. And the other two individuals in this population go through the week without becoming infected. So our first measure of incidence is this cumulative incident rate, where we have the average population. And we would assume, or we would estimate from this very basic example, that we've had 3 out of 5 of the cases, of 3 out of 5 members of the population became infected. So our cumulative incident rate is 0.6 cases per week. Our incident density, however, we're looking at this component of time. And so we're trying to understand how much time people are contributing. So let's think about the days. So this first person has contributed 5 days until he or she became infected, or he, in this example, became infected. Our second person contributed 6 days. Our third person contributed 1 day, our fourth person 3 days, and our last person 6 days. And when you add up all those days together, you get 21 total days. So our incidence density rate is 3 cases per 21 person days. So that's how many days people contributed, 21, as I said before. What that means is that we have 0.14 cases per person day. And what you can do with that estimate is then assume that if you were to follow 100 people from this population, you would expect 14 new cases per day. So when we think about exponential growth of the current COVID-19 virus and we think about new cases, we're really using information about incidence density to make some of these assumptions and to think about making the most precise estimates we can. And that can really help us understand the course of the disease over time. It's also important to note when we think about prevalence, how it can change given the day and given the course of the disease. So this first person who became infected at the end of the week was still infected. We don't know what's happened to him yet. The third person was infected for 2 days, hypothetically speaking, and then recovered and got better, and we continued to follow him. The fourth person, this woman, became infected on the 28th, lived for 2 more days, and then passed away on the 30th. So when we look at prevalence, we can see it really varies. So if we're looking at point prevalence on the 25th, it's 0 of 5. On the 29th, it's 1 out of 5 because only this woman is infected on the 25th. On the 31st, it's 1 out of 4 because we've no longer included this woman in the denominator because she's no longer alive. She's no longer part of the population at risk for being in the numerator. But if we look over time at the period prevalence for this week, it was 60%, 3 out of 5, just like we saw for the incidence in the first example. So these are just basic concepts. These are the tools that epidemiologists are using to measure the spread of disease. And I think it's important when you're looking at the news, when you're looking at the statistics for your region, for your county, for your country, for your state, think about how are they defining cases? Who are they using in the denominator, if anyone at all? What is the population at risk? And what is the period of observation in which they're presenting this data? All of these pieces of information can come together and help you interpret the data that's being presented to you. So that's all we have for this session. The next session, we're going to be talking about disease severity and case fatality. And as always, stay safe, stay healthy, and stay informed. Thanks.